Solve the following differential equation by using integrating factors. Okay, so how do we do that? Well, here's the steps. Step number one, you got to get y prime or dy dx alone, then the y stuff, then the other stuff. So let's do that. So I'm going to bring this term and jump it over. So step number one, I'm going to have y prime minus 4y equals x e to the x. So I've got the y prime alone, the y stuff, the other stuff. That's step number one. Step number two, find the integrating factor mu of x, which is e to the integral of p of x dx, where the p of x is whatever's next to y. So, okay. So what's next to y? Well, this is what's next to y. That's my p of x. Well, in step two, my mu, my integrating factor, is e to the integral p of x dx, which is e integral. What's p of x? Minus 4, so I'll put a minus 4. dx, what's that going to be? That's e to the minus 4x, right? Because you take the derivative of minus 4x, it'll go back to minus 4, won't it? So that's the integrating factor. So that's step two. And what do you do with that? Multiply the differential equation by that integrating factor, all three terms. So I'm going to say, oh, okay. So let's bring that on down. Here's the, bring down the differential equation. And I'm going to take that integrating factor, which is right here, and I'm going to multiply e to the minus 4x times e minus 4x times e minus 4x, right? Boom, boom, boom. Multiply all the way through by that. Okay. And we clean that up a little bit, not a lot. Y prime e to the minus 4x minus 4y e to the minus 4. Nothing really happens on the left side. On the right side, e to the x and e to the minus 4. This is 1x, take away 4x. That's e to the minus 3x. Remember those powers add, subtract to be on the e there, e to the minus 3x. Okay, so now step 4 says the left side is the derivative of the product of mu of x and y. So write it as such, right? d dx of the mu, the integrating factor, and the y. So, okay, is that true? The left side will be d dx of what? Of the y times the integrating factor. What's the integrating factor? E to the minus 4x. And the right side hasn't changed. Okay, now you can double check that left side. Is that true? Is the derivative of these two guys multiplied? Go back to this. Well, it's multiplied, so product rule, derivative of the first, y prime times the second unchanged. That looks good. Plus the first, there's the first, or there's the y anyway, times the derivative of this guy. What's the root of this guy? It's himself, but times minus 4. There's what, the minus 4. So yeah, that's right. Nice little trick. And then finally, step 5, integrate both sides of the differential equation. So now step 5. I'm going to bring in a big integral there and there. So we're integrating both sides. Something really nice happens here. The integral and the derivative cancel, right? Because they're opposites. So that just brings down ye to the minus 4x. Now on the right side, the integral will not cancel. We're going to have to do the integral. Why? Because there's no derivative there to cancel it. So I got to do it. Now, how do you do this kind of thing? Well, it's going to be by parts. And I'm going to show you a little shortcut. Whenever you have like an x and an eta something, it's a by parts. Let me show you a shortcut. Come up here. Here's the normal by parts rule, and that's good. But here's a shortcut. It's called a shortcut method. It's called integration by parts, called the tabular method or tabular integration. And so what you do is you just grab the first guy, x squared, and then you just go derivative 2x, derivative 2, derivative 0. Just keep taking the derivative until it goes all the way down to 0. Grab the second part, put that on the right side, and go integral. That's what the I stands for. And so you take derivative on the left side, integral on the right side. And then you put diagonal lines to connect them with pluses and minuses and pluses, switching back and forth. And that'll be your by parts integration automatically. Let me show you. So on this one, start with the x. Okay, and then I'll do what? I'll go derivative. What's derivative of x? 1. And I'll go derivative, and it's 0. Remember, you keep going until you get 0. And on the other side, e to the minus 3x, what am I going to do? Integrate, right? What's the integral of that? It's going to be minus 1/3 e to the minus 3x. You see how that I figured that out? Just think it backwards. If you took e to the minus 3x, it would multiply by a minus 3. It would cancel that minus 1/3, go right on back, wouldn't it? And so now do one more integral. It'll be positive 1/9 e to the minus 3x. See how that would work? If you did the integral, you go times minus 3, minus 3 over 9 be minus 1/3. It would go back. Okay, great. Now what? Now just connect this, put a plus over it, and connect this, put a minus over it. So you just do the diagonal lines, zip, zip. That'll be your biparts integral. So that means we have y e to the minus 4x equals, and what do we have here? X times minus 1/3 e to the minus 3x with a plus. Plus and minus going to be negative. Negative 1/3 x e to the minus 3x, right? So I got minus 1/3 e to the minus 3x and x. And now, next, this multiplies this. And there's a minus sign. So it's going to be minus 1/9 e to the minus 3x, right? 1 times negative 1/9 e to the minus 3x. And don't forget your plus constant. All right. Boy, these are long problems, huh? So we're getting close. Let's finish it up. So y e to the minus 4x. I got to get that y alone. I'm going to do a little trick. Probably know what it is. We'll multiply by e to the 3x in just a second. Just leaving some room here. Okay, let's do it. Let's multiply through. I got to get y alone. So multiply by e to the 4x. So these powers will add to be e to the 0, 1. So y is alone. Do it all the way through. E to the 4x, e to the 4x, e to the 4x. This will be minus 1/3 x. These powers will add e to the 1x, or just e to the x minus 1/9. These powers will add e to the x plus c e to the 4x. Okay. Last step is to plug in the information they gave us, which is right here. Plug in y of 0 is 9. Plug in y of 0 is 9. So plug in y of 0 is 9. So put in a 0 for x, and y will be 9. So we got 9 equals, this whole term is just 0. This term is just minus 1/9 because e to the 0 is 1, plus c times 1 because again e to the 0 is 1. All right, so now we're very close. Just add a 9 to both sides. Boom. That's going to be, what's that? 9 and a 90 with 81, 82 nines. You want to make it a fraction. You can just go to Desmos or just your handheld calculator. 9 plus a 9 is 81. I just wrote it. I just thought 9 and 1/9. And you multiply 9 times 9 is 81. Add 1, 82 ninths. So there's the constant. So we have got our answer. It's y equal, I'm going to grab y equals minus 1/3 x e to the x minus 1/9 e to the x plus the constant 82 ninths times e to the 4x. There we go. Is that right? Minus 1/3 x e to the x. Minus 1/3. Yeah, if you multiply this out, this will be minus 1/3 x e to the x. This will be minus 1/9 e to the x. Minus 1/9 e to the x. Perfect. And then 82 ninths e to the 4x. 82 ninths e to the 4x. Beautiful. We nailed it. There it is.